So the algorithm we're going to be working through right now is called counting duplicates. And our goal is to create a function called count duplicates that takes in an array of objects. Each object has a key called color that contains an array of strings of named colors. Color names are repeated in several of the arrays, and the function will return a new object that contains unique key names of each color and a number representing how many times that color has been referenced in any of the arrays. So if we had an input like this of this particular array that contains objects, each object contains a key called colors set to an array of colored names. And some of those names are repeated. So here we have blue is repeated there, there, and there. Red is repeated there and there. And so the colors are sometimes repeated, not all colors. I believe purple is just one instance of purple. And the output of the function would be to capture the names of the colors and how many times they were referenced within the arrays. So blue was referenced 3, purple was referenced once, red was referenced twice, and so on. So that's the goal of the function. This is our colors array. That's what we'll be working with. That's what we'll be passing into the function. Before we begin, though, there's two things that I really want to walk through so that we understand how to solve it. So this is just a small aspect of the problem, but it's a fairly large aspect of it. One of the things I want to determine is if the key exists in an object, and how do we do that? So if we have an object and we're looking for whatever that key is, so if I gave it a string of a key name, I would get one of two results. I would either get the value of the thing or undefined. Okay? If a key does not exist, you would get undefined. So let's take, I'm going to create an object so we can kind of walk through this. Colors object is equal to, and now we know, okay, let's give it a second. Sometimes REPL does that. I'm going to say colors object. That's going to be equal to an object, and I'm going to just start by giving it a color of blue, right? So blue, we'll say we found it one time, okay? Now, in order to just, kind of guarantee our logic up there, I'm just going to say console log and say colors object, and let's look for the string blue. And if I run this, we'll get 1 because that's what's here. I mean, if we found 2 instances of it and I put 2, we'd get 2. Awesome. The same would hold true. So console log colors object, and if we were looking, say, for purple, which has not been added as of yet, we would get undefined. So we're validating our assumptions. Key exists, we get the value. If a key does not exist, we get undefined. So these are the two ways to do it. So when we ultimately run our conditional logic, we could say things like if something exists, right? So we could say if, colors object, the key exists, then we could do something, right? And here I'll just say, our logic is going to be, if it exists, we're going to add, or better yet, increment the current value by 1, right? And so we know that blue exists, and we're going to get increment the current value by 1. I'm going to comment these out so they don't keep displaying. And then we can also say if colors object Now, if we do this, color purple, and we were to do something, I'm just going to add the console log, and then we're going to go back and edit this. Add the key of purple, and set it to 1. Okay? Now, if I do this, we're only getting, what's the issue here? Set it to a value of 1, add the key, console log, blip, blip. Let me see what happened here. Okay. I don't see why. Oh, if colors, if C. Here we go. Boop, my bad. Okay. So this didn't run. So we can't say that. Now what we could say is if color purple is equal to undefined, okay, that would work. Then we would be able to set it to 1. But a more terse way of doing this, instead of going the distance of having to say if it's equal to undefined, we could just put the bang operator here and say if it's not true, which it's not true because it's false, right? Which really becomes true. Hey, if it's false, then that's exactly the condition that I'm looking for. And it's not true, it's false. So conceptually that is true. And so now we could add a key of purple and set it to a value of 1. So ultimately, that's what we want to do. Okay, determine if it exists, determine if it does not exist. Now, the next thing would be, how do we add a key to an object? And in that instance, you're familiar with objects. It would be object, colors object, grab the object. We could say, dot purple. We could do this, right? And set that to 1. And now if I just do colors, console logged, colors obj, we should get purples in there. And that works. We could also say, we could also add colors object. We could also do red. We could put it like that, and we'd get the same thing. However, if it is going to be a variable, as it will be because we will be looping over and grabbing each value kind of dynamically through some sort of looping construct, then it's quite possible, or it is possible, that let color is going to be equal at sometime to a different color. That variable will be. So let's say we had red, purple. Let's do orange, right? Let's set it to orange. And if it's orange, then we're going to have to do colors object, and we're going to have to use color like this without a string because without the strings because we're enumerating a variable. And if we do this, we get, oh, we didn't set it to anything, is equal to 1, and now we have orange is set to a value. Okay? So we've got to keep this in mind because that's exactly the syntax that we are going to be using when we work through this. So before we begin working through the actual problem, I think it's important to work through pseudocode. Pseudocode is key in helping convey your thought process, the logic that you're working through mentally, and writing it down using a specific technique of pseudocode helps convey it to the interviewer as well as the other members of your team. So for this one, I'm going to just write pseudocode to work through a nested loops solution using if-else statements. Okay, so if I'm inside the function, the first thing that I would do is create a placeholder for this object that we are going to create in order to add the color name. So I'm going to say set a new variable called, I don't know, I'm going to call it count dupes to an empty object, right? Okay, now that we have it set, we can add keys and values to it at any point in time. The next thing we need to do is loop over the input array of objects, right? We're going to be passing in this particular array that contains objects. In this instance, it's 3, but it could be 300 or 3,000 objects. So we are going to loop over that array. Now, when we loop, I'm going to nest over because this is a double nested loop. So I have to first loop over the entire array and then each individual array of colors. So I'm going to put another loop over the array of colors in each object. Now, since I have loops, good pseudocode practice would be here to end loop as well as end the loop. So this is a clear visual indication to where the loop begins and where the loop ends, okay? And this helps convey to the team and any others who may be looking at the pseudocode where something begins and ends. Now, inside of the second loop, I'm going to run my if conditional statement, right? So if the key exists in the count dupes object, then we're going to do something, right? Then I am going to increase or add, however you want the terminology to be, increase the value by 1. By 1. Okay. Else, right? It doesn't exist. And then we would be doing add the key to count dupes, right? So add the key of the color name. So add the key, add a new key. How about that? Add a new key based set to the color name to count dupes, right? And then of course we would set its, oh, don't want it all to be uppercase, set its value to 1. Okay, what I want to point out here is that I'm using capital case for the action words and then lowercase for everything else. And so once again, pseudocode provides a visual indication of what's happening and the actions being performed as well. And so those actions are kind of highlighted using uppercase words. And the last step would be to return the count dupes object. Okay, object. Okay, and so that would kind of terminate our function and we would be finished at that point in time. Okay, so let's go write the code based on what we have up here. So I have this, I'm gonna uncomment this and just kind of, I'm gonna run the code. What do we get? We get really nothing, count dupes is undefined. I'm going to comment out all of this code up here, anything where we were doing console logs, so we don't see any additional console logs, and now we just have the one count dupes is undefined because that's what we're working with right here. Okay, so now we're going to work through it. Okay, so I'm going to follow my logic. My logic is set a new variable called count dupes to an empty object, and so I am going to say let obj is equal to an object. Now, since we're not reassigning object to anything new, I should probably say const, right? I'm not going to be reassigning this obj object to anything new, so const seems more appropriate. That would have worked. And now we're going to start our loop. Our first loop is for, and I'm going to say let I is equal to 0, right? And while I is less than array.length, I plus equals 1. And then we're going to work through our second loop. So for let j is equal to 0, while j is less than the array current elements, right? I represents the current element, dot colors because it contains the actual color themselves, dot length, okay? So once again, this represents the current element in the array. That object is returned. The object has a key called colors that returns an array, and we grab the length of that array. And then we do the same thing, I plus equals j plus equals 1. Curly brace, boop, there we go. All right, so here I'm going to grab the color, and I'm going to say, I don't know, const color is equal to array I, right? First array dot colors, bracket j, which represents the current element at that position. That would be the first element in the first iteration, second element, and on the second iteration. Now we're going to run our conditional logic. If obj, if the object contains the color, right? Because it's a variable, we're leaving off the single quotes. If the color exists, right, then we are going to say object color is equal to object color plus equals 1 plus equals 1. Okay, and then obviously if it does not exist, we'd be creating the key and setting it to 1, and then ultimately here, once our loop is completed, we would return object. Okay, so here we go, the count dupes object. So here I called it object. I'm going to call it count dupes because our logic here says return the count dupes object. I called it count dupes. So I'm going to go back here and just make an edit, count dupes, right? Count dupes, count dupes. That's what we called it. That's what we should stick with. That's our pseudocode. All right, cool. I'm going to run it, and object is not defined. Oh, dude. So I have to set this everywhere we go. Wherever there was object, I need to reset it and bloop. Okay, so let's take a look now. It should run, and we do get blue, there's 3, purple, there's 1, red, there's 2, black, there's 1, orange, 2, green, 1. Okay, so trust me that that is the correct solution. Everything is as it should be represented there. Okay, so that's our first solution, right? Okay. Now, our second solution, I'm just going to comment this out real quickly. Yeah, because all the functions are named the same. So I'm going to comment it out. Now, our second solution is really the same as the for loop, except we're only going to change it to a ternary operator. So I'm going to take the internals of this function right here, and I'm going to put it right here. Okay, move this over a little bit, right? Tab that over, and I'm going to tidy it up once I uncommented out the code. And let's tidy it up. Okay, I'm going to uncomment this, and then we can run it. Now, what I want to do is run a ternary operator on it. So when you code for a little bit, you realize anytime you have some condition that's just one or the other, a good use case for this, or a better substitution for the if-else, is a ternary operator. So instead of saying if-else here, we're going to convert this into a ternary operator. And by converting it, we're going to do this. So our condition is going to be this: if that is true. Okay, so if that's true, then we're going to do something, and we represent the do something by a question mark. So if that's true, we are going to do this. Okay, that's what we're going to do. Okay, I'm going to get rid of this. And the else now will be converted into a colon. Okay, so else, if that's not true, then we're going to do this. And once again, I am going to move this up here, get rid of the curly braces, because now we don't need the curly braces. Okay, so it's just a really terse way of writing it. It might not be as intuitive as writing an if-else statement. And so for a novice learning JavaScript, writing an if-else would be more intuitive. But after a little bit of coding, if-else's kind of run across this and see that that is a more novel way of writing it. So quite often I use ternary operators as well. So just wanted to show that as a possible solution. Okay, I'm going to comment this, and we're going to go down here, and we're going to do it using for each array loops. So using the array iterator for each, and we will do 2 for each loops along with the ternary operator again. So it's basically really the same kind of code, and I'm gonna create, I'm gonna do what do we do here? Const, right? Const, can't believe I just forgot const. Count dupes is equal to an object. And for our iteration, we're going to be using a for loop. So this is taking in an array here, and I'm going to reference the array as array. and we'll do array dot for each. Okay, and I'm going to pass in to this a particular object. I'm going to call it D for the data element. That's just kind of how I write my for each loops. And we have a nested for each loop, so I'm going to say D dot colors because we want to get the array inside of that object, and dot for each, which is our other loop. And here I'm going to say this is the exact color that we're looking for. And in all honesty, I'm really going to be taking this particular ternary operator and leveraging that here. Okay, so count dupes is our object. I'm taking in the color. And once again, if this is true, then we're just going to increase it by 1, else we're going to add it. And then down here, we return count dupes, right? So according to this should work. And once again, does work just as good as the others. It's just a terser way of writing it. After a while of using for loops, moving on to arrays, you start leveraging the array looping methods like for each, map, filter, and you got it. The next one is reduce. So reduce is a really cool use case for this as well. And reduce is something I kind of push in the class recently as a way to solve these problems in kind of a unique way. So what we'll be doing is the same thing, but this time I'm going to be using let me see, I think I can use const count dupes. This is going to be equal to the array, and we're going to be using the reduce method. Now, the reason why this time I'm storing it into, or I'm returning it, is because the reduce function, or the reduce method, returns something. Okay, that something can be an array, can be an object, it can be a number, it can be a string, but it is meant to return something. Okay, and inside of reduce, we're going to have 2 placeholders that we're going to use for this particular problem. And one's the accumulator, so I'm going to call it ACC, and the other will be the current value of the thing. So sometimes I use D. Here I'm just going to say value to distinguish it between its counterpart, the accumulator. And value is the thing that we're looping over, so val.colors, which is really the object. I should probably use object instead of val, but you get the idea. And in here, I'm using for each because I'm looping over this element, and color is the exact color. And so this accumulator is going to represent whatever data type we want it to represent. Okay, and that data type that we want it to represent gets defined right here. And I'm going to say in object. This is what I want it to be. Okay, so the fact that it's that, we are going to use the ternary operator again. So I'll just create a new ternary operator. We'll call it the accumulator. We're going to look at the color. If that object contains it, the accumulator, which is the object, will be equal to the color plus equals 1, right? Or plus equals 1, or it will be the accumulator color where it's equal to 1. We've first defined it, okay? What we also need to do is, looping through this, we need to return the accumulator. So at the end of this particular looping construct in reduce, we have to return the thing, so reduce keeps it in its own kind of space. Once this is completed, once all the loops are done, we can then return count dupes just as we did before. And if we run this once again, we're not seeing any changes here because it's the same thing. Now, if I went in just to see, like, is this really happening? I see green only happen once. So if I go up here and maybe add, I don't know, we'll add green here one more time. Let's just take a look. I feel like I want to see some of the colors change. And look, green is now 2. So we know that this solution works. It's reproducing all the same results. Okay, cool. So the last concept that we're going to be covering here in regards to solving this, which I think is really cool, and it's kind of a novel way of doing it too, is using recursion. Okay, and recursion is when the function calls itself. So when this function, I need to really pass this function everything it needs, because it's going to be calling itself and it's going to be using these values as a way to pass itself those values, but those values having been updated in one way, shape, or form. Okay, so when it comes to recursion, the concepts that we need to cover are base case, and the base case in recursion is this stops the function from calling itself, okay? Which really stops everything, and that function then indicates that we've reached the final end of our recursive journey and that we must work our way back to the very first function. Okay, we also have, I'm going to say, the action to be performed. This is like the actual logic that the function must perform. Okay, something's happening in here, and that's the action that we're going to do. And then the last is the recursive case. Okay, and this is really calling the function again and passing in whatever it needs. Okay, so we can see here my logic that I'm going to use to work through this is the length of the array. So there's something that I knew. The array has a certain number of elements, and if I can keep track of those number of elements and some sort of counter that knows we've gone through all of those elements by incrementing the counter one at a time, well, then I know I've reached the end. So if the array contains 3 elements and the length is equal to 3, well, then I've reached the last element in the array and I've completed, and I've reached my base case. So I'm going to work with that logic and say if length is equal to array.length, length. If this is true, then we are going to return the object that we passed in, okay, and that'll end it. Else our action to be performed will be, hey, grab the array and its length, which at the time of first iteration will be 0, and if we increment that number by 1, the next time it'll be the second element in the array. Okay, we'll grab the current elements at that position, which has a key of colors, and we'll do the for each loop in color. And then here, once again, this is our ternary operator yet once again, and our object will either have a key. If it does have a key of that color, then of course we are going to set it to be the color plus equals 1, else we're going to set it to be 1 because that's the first time that we encountered it. Okay. We also need to increment length is equal to length plus equals 1, or just maybe we'll just do length plus equals 1 plus equals 1. Okay. So we're going to increment length by 1, and then we're going to call the function again. So we are going to return count duplicates, and we are going to be passing in the array. We're going to be passing the length, which is increased by 1, and we're going to be passing in the current object. So hopefully this works. And what did I do wrong here? So looks plus equals 1. All right, so it's not going to do, because it's let when it's length. Duh. Okay, so it works just as we suspected, right? Or you don't know recursion, you'll just have to trust me on that it worked. Okay, so that's one version of recursion, and we do have one more version of recursion that I kind of wanted to cover. Once again, we're just kind of getting fancier and fancier with the solutions here. Here, this time I've gotten rid of length altogether, because another way to solve this would be to, let's do this. I'm going to say the array element at position 0. Okay, I'm always going to grab the first element, and you'll see why. Dot for each our color And the object that we're passing in, does the color exist, right? Does the color exist? If it does exist, then the object will get color. And here we can just, we can just say plus 1. I'm going to try to even make it shorter. Or we're going to set it to 1. Okay, so this is kind of another nifty way of doing it. Think of the ternary operator, but even shorter than that. So what we're saying is, if this exists, we will set it to itself plus 1, whatever the value of this return, plus 1, or we'll just set it to 1. So another kind of nifty way of doing it. That's I'm going to say that this was our action. We're going to do this. And then what we're also going to do here is we're going to remove the first element from the array. All right, so we have one less thing to work with. And then we're going to move on to our kind of recursive and base case. This is both our recursive and base case scenarios here. And so what I'm going to return is array.length, right? If it's not equal to 0, okay, then we still have something to work with. So if it's not equal to 0, so then count duplicates, call the function again, passing it in the array and passing it the current object, okay? If that's not the case, if it is equal to 0, then we're going to return the object because we've reached the final end of our looping construct. So we'll return the actual object itself. And let's see, okay, col is not defined. What did I do here? Color. Oh, because I put col here and it's color. Boom, and there we go. And then we solved it. So it's just another way of solving the problem recursively. As we can see before, there's multiple ways to solve a problem in the first place, and this one solves it a different way recursively. And I kind of like this way better than the first way. Once again, using if-else statements or just if statements, I prefer to do it kind of like this, but the other way might be more intuitive. Cool. Glad I got the chance to show you counting dupes, and hopefully you picked up a few tips and tricks here in solving this problem as well as any future algorithms.